Every machine that fails gives a warning, not through noise, not through heat, but through vibration. If you can understand vibration, you can prevent 90% of industrial failures. Today, we're going to dive deep into the language of machines. We'll explore why understanding these signals is the key to modern predictive maintenance and how you can apply it. Welcome back. I'm going to show you exactly what vibration really is, when to measure acceleration, velocity, and displacement, and the critical ISO standards used in the industry today to keep things running smoothly. And most importantly, I'll teach you how to analyze these readings like a pro. We'll look at the tools, the math, and the standards. Let's get right inside the heartbeat of industrial machines. Vibration is simply oscillatory motion of a machine component. Think of a motor shaft rotating. Even the smallest movement manifests as a signal. In industries, this isn't just noise, it's critical data. There are three main types: free vibration, forced vibration, and resonance. In professional maintenance, we don't treat this as a nuisance. We treat it as the most valuable stream of data we have. Resonance is the most dangerous state. It occurs when external forces match the natural frequency of the machine, leading to massive, destructive amplification that can tear equipment apart. A vibration measuring unit consists of an accelerometer sensor, a signal processor, and an analyzer. It's a sophisticated system designed to capture the smallest movements and convert them. It converts raw mechanical movement into electrical signals. This signal path must be clear and interference-free to ensure the data we're analyzing is an accurate reflection of machine health. Sensors are strategically mounted on bearings or casing points. We typically measure at both the drive end and non-drive end to get a full picture of the shaft's stability. There are three fundamental vibration parameters you must master: displacement, velocity, and acceleration. Knowing which one to focus on is what separates the novices from the professionals. Displacement measures how far the machine moves from its resting position. It's measured in micrometers and is your primary tool for low-frequency vibration, especially in large turbines and slow journal bearings. Velocity measures the speed of that vibration in MMS. It is the gold standard for general machine health monitoring, typically used for pumps, motors, and compressors operating in standard speed ranges. Acceleration measures the rate of change of velocity. It is best for high-frequency signals, making it essential for detecting bearing wear and gear mesh defects long before they become visible. When do you use each? Machine speed under 600 RPM calls for displacement. Between 600 and 12,000, velocity is your primary tool. And for gearboxes and high-speed bearings, acceleration is key. The golden rule is simple to remember: low frequency for displacement, mid-frequency for velocity, and high frequency for acceleration. Follow this, and your data will always make sense. Industries follow strict ISO standards like 10816 and 20816. These define severity zones. Zone A is good, B is acceptable, C is unsatisfactory, and Zone D means you must shut down immediately. ISO 13373 provides guidelines for monitoring and interpretation, while ISO 7919 focuses on shaft vibration. These standards ensure your maintenance decisions are based on global benchmarks, not guesswork. Correct measurement requires checking bearings in vertical, horizontal, and axial directions. This 3D profile helps distinguish between different types of faults, like imbalance or misalignment. Avoid mounting on thin covers or loose brackets. Always keep the sensor tight and perpendicular to the surface. Poor mounting can lead to false readings that could hide a critical machine fault. To analyze like a pro, start by checking the overall RMS value. For velocity, readings under 2.8 are typically good, while anything over 7.1 is a serious warning that requires immediate investigation. Never analyze a single data point in isolation. Track your readings over time. A sudden upward trend is your clearest warning of an upcoming failure, allowing you to plan maintenance before a disaster occurs. We've seen this save millions in real-world settings. From detecting pump bearing failure weeks in advance to identifying motor imbalance before it triggered a factory-wide shutdown, these techniques are the backbone of reliability. Vibration is the heartbeat of your industry. Understand the units, Follow the standards, and you'll stay ahead of every failure. Thank you for joining this masterclass on machine vibration analysis. ISO standards also classify machines by size and mounting. Class 1 is small equipment, Class 2 is medium, while Class 3 and 4 cover large machines with rigid or soft foundations. Your vibration limits will vary depending on which class your machine falls into. Advanced analysis uses the fast Fourier transform, or FFT. A dominant peak at 1x RPM typically points to imbalance, while a 2x RPM peak suggests misalignment. These patterns are your diagnostic key. A true pro looks at both the time waveform and the spectrum. While the spectrum tells you what is wrong through frequency peaks, the time waveform can reveal how it's happening, such as impacts from broken gear teeth or loose components. Thank you for watching this vibration analysis masterclass. We hope this knowledge helps you improve your plant reliability and machinery uptime. Stay curious, keep measuring, and keep learning. Subscribe to Simple Gaian for more industry-leading intelligence. Master the heartbeat of your machines and stay ahead of the curve. See you in our next masterclass.